Yes, friends. Now, in my earlier videos, I have defined you the Laplace transform and also some examples of Laplace transformation. In this video, I have defined you some examples of inverse Laplace transform. Okay. Now, the first example is, let us suppose that you find out Laplace inverse 6s minus 4, and second one Laplace inverse e to the power minus 5s divided by s minus 2 to the power 4. Yes, now to solve this question, yes, okay. Now this Laplace inverse 6s minus 4 divided by s square minus 4s plus 20. Yes, this can be written as, now in this question you make the denominator in the perfect square like that. Okay, so this can be written as Laplace inverse, here is 6s minus 4, dividing, now make this to be perfect square form, so this can be written as s minus 2 whole square. Yes, 4s plus 4, so adding 4 and subtracting 4, so you become this will plus 16. Yes, now you see this is this and this expression is the same. Okay, yes. Now, so to make the function, whole function by we want to use in this expression is to property of shifting property. Yes, for the shifting property, this expression can be written as 6, yes, Laplace inverse, making this one. Here is the function is the s in denominator, here is s minus 2, so in the numerator you also make the term as a s minus 2. So if you take the common, or you can say that plus 12 minus 12, then this become 6s 6 comma s minus 2 like that. Okay, so x6 s minus 2, yes, plus 8. Okay, here you plus 12 and minus 12, so this becomes this one. Okay, and denominator is again s minus 2 whole square plus 16. Just clear? Here you see the here in whole the function is s minus 2 is here, s minus 2 is here. Yes, so this can again be written as 6 Laplace inverse, yes, making this to then the linear property, this, yes, s minus 2 divided by s minus 2 whole square plus 16, yes, again this can be written as plus 8, yes, so this can be written as plus 8 Laplace inverse, and here is 1, so 1 divided by s minus 2 whole square plus 16. Yes, clear? Now we apply the by shifting first shifting property. Yes, by first shifting property. Yes, according to the first shifting property, you know the properties earlier I have defined and also proved this property. Yes, with the first shifting property, this can be written as, if here we can define within bracket, if Laplace inverse, yes, Fs, this is equal to Ft, yes, then Laplace inverse f of s minus a, yes, this is equal to e to the power at ft. Yes, I think you know this property. This is the first shifting property. If Laplace inverse fs is equal to ft, then Laplace inverse f of s minus a is equal to e to the power at. Yes, you know this. So you apply here in this question. Yes. So you apply here in place of the function is s minus 2. Okay, here is s minus 2. So the whole term becoming s by s minus 2 whole square, yes, plus s square. So, and you know the Laplace inverse s by s square plus 16. This is cos in the form of cos. Yes. So, this is equal to 6 and 80. A is here 2. So, this e to the power 80. So, e to the power, yes, 2t and also cos 4t. Yes, clear? And similarly here, in the next row, plus 8, and this become, the whole function is again is a function of s minus 2 like that. So here you can also apply the first shifting property. Yes, e to the power 80, that is, here is 1 by a is here a is equal to s square plus a square, and a is 4a. So this can be written as 1 by a, that is 1 by 4 e to the power 2t sine 4t. Is clear? And therefore this can be written as, the answer is 2. Yes, here is again 2. So 2 e to the power 2t, and within bracket you can see, you can 3 cos 4t plus sine 4t. Yes. Clear? Okay, I think you have cleared this question. Yes. Similarly, you can do the another question. Next one is Laplace inverse e to the power minus 5s divided by s minus 2. Yes. This question you can also easily you can solve by again here you using first one, you use the first shifting property, now second shifting property. Yes, the second one. Yes, this is the second one. This is the first one, and similarly the second one. Second one is Laplace inverse e to the power minus 5s divided by s minus 2 to the power 4. Yes, the question is like that. Yes. So if you apply again the first shifting property here, 1 by s minus 2, then this can be written as you consider here only first you find out the one Laplace inverse 1 by s minus 2 to the power 4. What is this one? Yes. So now in this question, okay, now you apply the second shifting property and now you get the result. Okay. Since Laplace inverse is 1 by s minus 2 to the power 4, yes, this is equal to, here earlier you have also defined this first property, first shifting property, then here is a is 2, that is e to the power 2t, yes, and Laplace inverse 1 by s4, and which you know which is equal to e to the power 2t, and here is t cube by factorial 3. Yes. Laplace inverse this one you get. Yes. And therefore, yes, therefore, Laplace inverse this e to the power minus 5s and divided by s minus 2 to the power 4. Yes, this is equal to 1 by, here is factorial 3, that is 1 by 6. 1 by 6 t minus 5 e to the power 2 t minus 5 for t is greater than 5. Here you apply the second shifting property, and this is 0 for t is less than 5. Yes, because here you can obtain the second shifting property. And also I think you know the result of second shifting property. According to the second shifting property, yes, second shifting property, second shifting property, you know, yes, which is if Laplace inverse Fs is equal to Ft, yes, then Laplace inverse, yes, this one you know, e to the power as f of s is equal to gt, where gt, yes, where gt, yes, this is equal to, you proved earlier, second proof of the second property, yes, this is equal to f of t minus a for t is greater than a, and again is equal to 0 for t is less than a. Yes, clear? Here we are using this property. Yes. So in place of, because f of t, here you see f of s is equal to f of t. You have obtained the Laplace inverse of this one, that is, this become f of t. F of t is this one, 2t. So here is, this is a to the power s, because the Laplace of ft is equal to f of s, a s. Yes, so a is here is 2. Yes, then f of this become, where gt is equal to t minus a, that is t minus 2 according to, but here in this question e to the power minus 5s, because you operate here this to be as a ft. Here this is completed. Actually this become ft. It is completed. Now substituting this property, and you get a is 5. So substituting t minus a, that is t minus 5. In whole the term you replace this to be t minus 1. So by this property you can also obtain this one. Yes. So by using this one, yes. Okay, this is the second shifting property. So your answer become, where in this question you can say, yes, for this, where, yes, where the substituting if this one, then you can say that u t minus a, this is equal to t minus 5, not a. a is here is 5. T minus 5 is 1. Yes, if t is greater than 5, and similarly this is equal to 0 if t is less than 5. Yes, according to this, according to chapter. Yes, GT, or you can substitute anywhere. GT you can say, or UT, or like that. Okay, yes, clear it. Therefore the solution is this one. Yes, okay, in next video I will define some other questions. Okay, thank you.